Good morning, chemistry students. I forgot to put that on here, that this was chemistry 1A. Here are your chapter 6, day 4 notes. The notes today are going to cover all of chapter 6, section 4. And today you're going to learn how to, if you're given the name, write the formula for an ionic compound. And you're also going to learn how, if you're given the formula, how to name an ionic compound. So today we'll be talking about ionic compounds. Again, it's going to be helpful to have your helper sheet handy and your periodic table handy as we go through these notes. So the title of this section is Ionic Compounds. Remember, we know that something is an ionic compound because it's a metal and a nonmetal, or it has a polyatomic ion. So ionic compounds mean we have a metal and a nonmetal. Remember, metals are to the left and below our heavy stair-step line. Nonmetals are to the right and above our heavy stair-step line on our periodic table. You have 10 polyatomic ions you should have memorized. If you don't have those memorized, you might want to have that piece of paper also handy today. And you have a helper sheet that has some polyatomic ions on it as well. So, it used to be, that the person to discover an element or a compound got to name it. That used to be sort of the perk, if you will, of having discovered an element or compound. And you can see some evidence of this on the periodic table. For example, element number 101 is named in honor of Dmitri Mendeleev, and it's mendelevium. Element number 99 is named in honor of Albert Einstein and is einsteinium. Element number 97 is berkelium, and the University of California, Berkeley, throughout the 80s and 90s, for sure, and maybe even back further in history than that, used to be the place to be for doing chemistry research. So that was a great university, and somebody probably from the University of California, Berkeley, discovered element number 97. So you see quite a bit of this throughout your periodic table with the element names, that it used to be that the person who discovered that element or compound got to name it. The problem, or kind of give you an example of this, at the dentist's office, some of you might have had laughing gas before. Which is N2O. Now, again, why do they call it laughing gas? Well, if you've had it, it sort of makes you a little lightheaded. Things that maybe aren't normally funny seem funny, right? So they named it laughing gas because of some of the characteristics it gave you as a person. However, the problem with the name laughing gas is it really doesn't tell you anything about the element. Another example of this is baking soda. Baking soda is a compound. It's sodium hydrogen carbonate. So, the problem with just allowing the person who discovered the element or the compound with getting to name it is that these names, the names they chose, they didn't always provide any information about the compound. And so scientists, chemists, felt that they needed a systematic method. So they needed some way that all of the chemists around the world were naming things the same way, because again, one of the things science has always done is publish their knowledge. And so a scientist might do an experiment here in the United States, and a scientist in China or Japan might repeat that experiment and make sure that they get the same results. Well, you have to be then calling substances and compounds the same thing here in the United States as they call it in China or Japan, so that everybody is able to use the same substance in our reactions. So chemists really felt there needed a systematic method for naming compounds and writing formulas. So we're going to start by talking about binary compounds. Binary compounds just mean that we're talking about compounds made of two different elements. Now that doesn't mean that there can't be more than just like one single atom and another single atom. All we mean is like water would be considered a binary compound because it contains both hydrogen and oxygen, just two different elements. And again, today we're focusing on ionic compounds. And remember that there were a couple rules about writing formulas for ionic compounds that we discovered on one of our chem quests. One of those rules is that they have to overall be neutral. So remember, that meant that our total positive charge equaled our total negative charge. Okay. Another way to say that is that the charges must balance. And then remember, our second rule was that we always write the positively charged ion first. Okay, and that's true in both the formula and the name. Okay. So we've talked about these rules before. Okay, we've been introduced to this, that overall an ionic compound has to be neutral, so our total positive charge equals our total negative charge. Our charges have to balance. And we always write the positively charged ion first. So, to write the formula of a binary ionic compound, first write the symbol of the cation, which remember is our positively charged ion, and then the anion, then add subscripts as needed to balance the charges. So we're going to take a look at some. If we combine potassium and chlorine. So again, you're going to want to be looking at your periodic table. And potassium is in group 1A, so it has a 1 valence electron, so its choices are to lose 1 or gain 7. Easier to lose 1, so it gets a charge of +1. Chlorine is in group 7A. It has 7 valence electrons, so the question is it easier to lose 7 or gain 1? It's easier to gain 1, so it has a charge of -1. So to combine these so that I overall have a neutral charge, I would combine them in a 1-to-1 ratio because I have a +1 and a -1. And I always write the positively charged one first, so my formula would be KCl. If I have an iron 2 ion and oxygen, right? Iron 2, that Roman numeral, that's that stock system of naming. And remember that Roman numeral is telling me the charge on my iron. So my symbol for iron when you look at your periodic table is Fe. The 2 is telling me its charge is +2. And oxygen has a charge of -2 because it's in group 6A, so it could either lose 6 or gain 2, so it's going to gain 2. So +2, -2, I have to combine these in a 1-to-1 ratio, so my formula is going to be FeO. If I'm talking about a calcium forming a compound with a bromine, calcium is in group 2A. It has 2 valence electrons. Its choices are to lose those 2 or gain 6. It's going to lose 2, so it has a charge of +2. Bromine is in group 7A. That means it has 7 valence electrons. Its choices are to lose those 7 or gain 1. It's going to gain 1, so it has a -1 charge. Remember, I have to combine these so that overall I have no charge. So with one positively 2 charged calcium, I'm going to need 2 bromides. So my formula is going to be CaBr2. So remember, in this notation, our subscripts indicate the number of atoms, and back on that ChemQuest, we talked about a shortcut way to do this. And everyone loves a shortcut. There are kind of 4 steps to this. We write our symbols. We write our charges. We crisscross. Only the numbers, not the signs. And our 4th step is we make sure it's the lowest whole number ratio. So typically we kind of recite this way. We say symbols, charges, crisscross, lowest whole number ratio. To write the formula for an ionic compound, we do symbols, charges, crisscross, lowest whole number ratio. Again, to write the formula for an ionic compound, we do symbols, charges, crisscross, lowest whole number ratio. So, what does that look like? Okay. If we look at iron with a +3 charge and oxygen, so I write my symbols, always my positively charged ion first. Then I do my charges. My iron charge is +3. Oxygen is in a tall column of the periodic table. So oxygen has 6 valence electrons, so its choices are to lose those 6 or gain 2. It's going to gain 2, so it has a charge of -2. Now I'm going to crisscross, but just the numbers, not the sides. So my formula becomes Fe2O3. Now I should check that it's the lowest whole number ratio. Is 2 to 3 the lowest whole number ratio? Indeed. Now, to check that it really has followed our 2 rules, right? Overall total positive charge equals total negative. Okay. Iron has a charge of +3, and there's 2 of them, so that's a +6 charge total. There are 3 oxygens, each with a -6 charge, so that gives me a 0 charge. So our crisscross method works, and it's shorter. So I would like you to practice with these. So if I give you the form or the symbols, I want you to write basically you're writing formulas. Sorry, you're going to write formulas for all of these. So barium and sulfur, lithium and oxygen, calcium and nitrogen, copper 2 and iodine, sodium iodide, stannous, chloride, potassium, sulfide, and calcium iodide. So again, I want you to practice this. So I want you to pause the video if that's what it's going to take to give you time to come up with these formulas. If you need more time than I give you, you can pause the video. So starting with barium. Barium is in group 2A. It has 2 valence electrons. So is it going to lose 2 or gain 6? It's going to lose 2, so it has a +2 charge. Sulfur is in group 6A. It has 6 valence electrons. So is it going to lose 6 or gain 2? It's going to gain 2. So I have Ba +2, S -2. I crisscross down. I have Ba2S, right? So I've done my symbols, my charges, my crisscross. Now I need to make sure it's lowest whole number ratio. Is Ba2S2 the lowest whole number ratio? Nope. So I should rewrite this as BAS. Next we have lithium and oxygen. Lithium is in group 1A. It has 1 valence electron. So is it easier to lose 1 or gain 7? Lose 1, so it has a +1 charge. Oxygen is in group 6A. It has 6 valence electrons. Is it easier to lose 6 or gain 2? Gain 2, so it has a charge of -2. So I have Li +1, O -2. I crisscross down, and I have Li2O. Is 2 to 1 the lowest whole number ratio? It is. The third one, we have calcium and nitrogen. Calcium is in group 2A. It has 2 valence electrons. So is it easier to lose 2 or gain 6? It's easier to lose 2, so it has a charge of +2. Nitrogen is in group 5A. That means it has 5 valence electrons. Is it easier to lose 5 or gain 3? Gain 3. Okay. So, I have to make some room. Okay. I have Ca with a +2 charge, nitrogen with a -3. I crisscross down. And is 3 to 2 the lowest whole number ratio? Yes. So my formula is Ca3N2. For copper, and it already told us the charge, and they had to do that because it's a transition metal and has more than one possible charge. Iodine is in group 7A, so its choices are to lose 7 or gain 1. It's going to gain 1, so it has a -1 charge. So I have a Cu with a +2 charge, I with a -1. I crisscross down, and I have CuI2 as my formula. Next, I have a name given, a sodium iodide. So that means that I have to find the symbols and charges and crisscross and lowest whole number ratio for these. Okay. So again, my symbol for sodium is Na. Sodium is in group 1A, so it can lose 1 or gain 7. It's going to lose 1, so it has a charge of +1. Iodide is in group 7A. It has a charge. It has 7 valence electrons, so it's going to be lose 7 or gain 1. It's going to gain 1, so I would crisscross down 1s, and NaI would be my formula. For stannous chloride, I'm going to have to use my helper sheet because Stan is on my helper sheet. So I find what Stan is, and Stan is tin, and my symbol for tin is Sn. Now, the fact that it's an us ending, remember that means it's the lower charge tin. So when I look at tin on my helper sheet, it has a charge of +2 and +4. Because it's the us, it's the +2 charge tin. Chloride is Cl, a charge of -1 because it's in group 7A, so it gains 1 electron. So my formula is SnCl2. Potassium sulfide. Potassium is K. It's in group 1A, so it can lose 1 or gain 7. It's going to lose 1. Sulfide is S. It's in group 6A. It could lose 6 or gain 2. It's going to gain 2. I crisscross down, and I get K2S. And calcium iodide. My symbol for calcium is Ca. It's in group 2A, so it could lose 2 or gain 6. It's going to lose 2. Symbol for iodine is I. Okay. It is in group 7A, so it can lose 7 or gain 1. It's going to gain 1. So my formula is CaI2 when I crisscross down. So this is how we, given the name, write the formula for ionic compounds. Again, we're going to write our symbols, write our charges, crisscross, make sure it's the lowest whole number ratio. Symbols, charges, crisscross, lowest whole number ratio. How do we name binary ionic compounds then? It's really fairly straightforward in that we are going to combine the name of the ions. So to name any binary ionic compound, place the cation. Name first, followed by the anion name. So group B elements, remember again we're talking about our tall columns. So remember for the tall columns on our periodic table, to name cations, positively charged ions, it's just the element name plus the word ion. To name group A nonmetals, so negatively charged ions, remember we took our element name, it lost its ending, and it got an "-ide". So basically, to name a group A element binary compound, it's going to be the metal plus the nonmetal ending in "-ide". So if we kind of come back to these examples that we did here, and we name them, right? Ba, that's barium ion. S is sulfide, so this would be barium sulfide. Li plus, that's lithium ion. O -2 oxide, this is lithium oxide. Ca plus 2 calcium ion. N is nitride, so this is calcium nitride. Now, this one we're going to talk about in more detail in just a couple minutes. But remember, copper can be named twice, so I'm going to have to name this twice. So this is copper 2 iodide. And then I use my helper sheet. Copper is Cup. This was the +2 charge of copper, which is the higher, so it would be ic iodide is the other name. Okay, and the other ones I had already given you names for. So for the group B elements, remember this is going to be, and as we just saw with copper, a little bit more complicated. Because of more than one possible charge. So again, somehow, when we name them, we have to communicate what charge it is. So when we're dealing with group B elements, our first question is, does the metal or the element have more than one possible charge? How are we going to check that? We're going to use our helper sheet. Again, I don't expect you to have this memorized. Now remember, on our helper sheet, when we looked at our helper sheet yesterday, right, there were 4 elements at the bottom of that didn't have more than one possible charge. Silver, cadmium, zinc, and scandium. We don't have to, we would name those the same way as we did our group A elements. So we'll kind of answer the no, right? So maybe it's silver, cadmium, zinc, or scandium. No, they don't have more than one possible charge, so that is just the name of the metal plus the nonmetal. just like we did here, right? Exactly the same as this, okay? Our metal plus our non-metal ending in "ide." However, most of our group B elements, our short columns, do have more than one possible charge, okay? So that means that we're going to name it twice. Using both the stock and classical systems. Remember, stock system, we're going to use the charge on the ion as a Roman numeral. With the classical, we have to use the Latin root in either "ic" or "us" ending. That being said, then our concern is what charge does the cation have? And to figure that out, we're going to look at our anion. Okay. And we're going to look at our total negative charge and then determine what our total positive charge has to be, and then what the charge on the individual cation is. So let's look at one together before I give you some to practice with. So let's look at, okay, let's look at these two. So let's look at the CuO first. So we're asked to name this, right? So we know it's an ionic compound because it's a metal and a nonmetal. So we look at our copper, and our copper is in a short column of our periodic table. So that means we look at our helper sheet. Copper's on our helper sheet. It has more than one possible charge. So I know I'm going to name this twice. I need to figure out what charge this copper has. To do that, I'm going to look at oxygen. Oxygen is in group 6A. It has 6 valence electrons, so it is easier for it to gain 2 and get a -2 charge than it is to lose 6. Now, that means that my total negative charge has to equal my total positive charge. So because there's only one copper, copper has to have a charge of +2. So to name this compound, this is going to be copper 2 oxide. That's one name. Now I also have to do the Latin one, so this is Cup. And then copper's possible charges on your helper sheet are +1 or +2. The +2 is the higher charge one, so it gets the ic ending, oxide. Now, we see this compound is different. Its formula is different, which means its name should be different. So we do the same thing, right? We know it's an ionic compound, it's a metal and a nonmetal. We look at our metal. Copper's in a short column of our periodic table, which means we have to check our helper sheet to see if it has more than one possible charge. It does. So I need to figure out what charges copper has. So again, I look at my anion, which is oxygen. Oxygen has a charge of -2 because it has 6 valence electrons, so it's easier to gain 2. So my total negative charge is -2 now. Now, my total positive charge has to be +2, but notice this time I have 2 coppers. So that +2 charge is divided by having 2 coppers, which means each copper has a charge of +1. So this is copper with a +1 charge. So this is copper 1 oxide. This is coop, and +1 is the lower charge one, so us oxide. Okay, so that's how you have to do that for group B elements. Now, if it was a silver compound, I would just name it silver plus the name of its nonmetal, because silver on my helper sheet only has one possible charge. So I have some practice ones for you here. Again, I'm going to get right into on the video correcting these or doing these, but you should pause the video at this point and take your time and name these. And remember, if it's a transition metal, a short column of the periodic table, a group B element, and it has more than one possible charge, you have to name it twice. So we have SNO for our first one. So I have a metal, SN, and a non-metal O, so I know it's an ionic compound. So I look at my SN. SN is not really in a short column, but it's underneath that heavy stair-step line, which means I should look at my helper sheet. SN is tin, and tin is on my helper sheet. So I know I'm going to have to name this twice. Okay. And I need to figure out what charge that tin has. So again, I look at my oxygen. Oxygen has 6 valence electrons, so it has a charge of -2. There's only one tin, so this is tin with a charge of +2. So one name for this is tin 2 oxide. Because, again, tin 2 ion, and oxygen, because it's negatively charged, becomes oxide. My other name, my root for tin is Stan. I look at my helper sheet. The 2 charges on my helper sheet for tin are +2 and +4. So this is the lower charge one, so it's us. And oxygen is still oxide. So next I have SNO2. Again, for the same reason, I'm going to have to name this twice, right? It's a metal and a non-metal. Tin is in a short column underneath my heavy stair-step line. It's on my helper sheet. So again, I know I'm going to name this twice. Again, I have to look at my oxygen, which has a charge of -2. There's 2 of them this time, so my total negative charge is -4. There's only one tin, so this tin has to have a charge of +4. So this is tin 4 oxide. It's still Stan, but now +4 is the higher charged one, so it's ick oxide. Next I have ZNS. So Zn is a metal. First off, it's a metal and a non-metal, so it's an ionic compound. Zn is in a short column, so that means I'm going to look at my helper sheet. But when I look at my helper sheet, zinc only has one possible charge, so I don't have to worry about naming this twice because it doesn't have more than one possible charge. So Zn as an ion would be zinc ion. S as an ion is sulfide, so the name of this compound is zinc sulfide. No Roman numerals, no 2 names, because zinc only has one possible charge on my helper sheet. All right. Potassium metal, chlorine nonmetal, so I have an ionic compound. Potassium's in a tall column of my periodic table, so I only have to name it one time. So K as an ion is potassium ion. Cl as an ion is chloride. So this is potassium chloride. Only one name because potassium's in a tall column of my periodic table. BaO, metal, nonmetal, so it's an ionic compound. Ba, tall column of my periodic table, which means I only have to name it twice or once. So Ba is barium ion, O is oxide, so this is barium oxide. CuBr2, so copper, metal, and nonmetal, so ionic compound. Cu is in a short column of my periodic table, which means I look at my helper sheet. Copper is on my helper sheet. It has more than one possible charge, so I need to figure out what charge that copper has. I look at my bromine. Bromine is in group 7A. It has 7 valence electrons, so it's easier for it to gain 1. There's 2 of them, so my total negative charge is -2. I only have 1 of them, so that means I have a +2 charged copper. So, again, because it is on my helper sheet and has more than one possible charge, I'm going to name it twice. So that's copper 2 and bromide. And then copper is Cup. +2 is my higher charged one, so it's the ic bromide. CaO, metal and nonmetal, so it's an ionic compound. Ca, tall column, so I don't have to name it twice. Ca is calcium ion, O is oxide. This is calcium oxide. Cu2S, metal, nonmetal, so it's an ionic compound. Cu, short column of my periodic table. I check my helper sheet. Copper's on there. It has more than one possible charge. So I'm going to look at my sulfur, which has 6 valence electrons, so it could lose 6 or gain 2. It's going to gain 2. There's only one of them, so I have a total charge of -2, but I have 2 coppers. So each copper has a charge of +1. So this is copper, Roman numeral 1, sulfide. And my other name is Cup, because that's the lower charged one, sulfide. So again, because it was on my helper sheet and had more than one possible charge, I have to name it twice. Fe and S, metal and nonmetal, therefore it's an ionic compound. Fe, short column of my periodic table, that means I check my helper sheet. Fe's iron. Iron's on my helper sheet. It has more than one possible charge. So I'm going to have to name this twice. Okay. And I'm going to look at my sulfur, which again we just looked at before, right? Still has a charge of -2. There's one of it, so I have a -2 charge over 1. So I have a +2 charge for my iron. So this is iron with a Roman numeral 2 sulfide. My Latin root for iron is Fer. And the 2 charges for iron are +2 and +3, so this is the lower charged one. So this is Us sulfide. And AlF3. Al, metal and a nonmetal, so it's an ionic compound. Al is in a tall column, so I won't have to name this twice. So Al is aluminum ion, F is fluoride, so this is aluminum fluoride. So hopefully that helped you a little bit with writing these. All right. Ternary ionic compounds, right? So we were talking about binary compounds that just have 2 different elements in them. When we talk about a ternary ionic compound, we're going to be talking about compounds that have more than 2 elements in them. Okay. So when we talk about ternary ionic compounds, we're going to be talking about a compound that contains atoms of 3 different elements. That's going to mean for us that there is usually a polyatomic ion. So to write the formula for a compound with a polyatomic ion, first we're going to write the symbol or the formula for the cation, followed by the symbol or the formula for the anion. Then we're going to add subscripts as needed to balance the charges. So these are still ionic compounds. So we still have to follow those 2 rules, that our overall positive charge has to equal our total negative charge, and that we write our positively charged ion first. Whenever more than one polyatomic ion is needed to balance the charges, in an ionic compound, we use parentheses to set off the polyatomic ion in the formula. To name a compound containing a polyatomic ion, state the cation name, first, and then the anion name, if the cation is a metallic element, with more than one possible charge, name it twice. So basically, what we have said is that to write the formula is done the same as what we did, right? We're going to write symbols, write charges, crisscross, make sure it's the lowest whole number ratio. The only difference is we must put the ion in parentheses if there's more than one. And in terms of naming them, our name is done the same. We're going to combine the name of the cation and the anion. Okay, so when we say formula is done the same, we're talking about symbols, charges, crisscross, okay, lowest whole number ratio. The only difference being, if we need more than one polyatomic ion, we have to put that polyatomic ion in parentheses. And again, we saw this already on our ChemQuest. Okay, naming done the same. So what I mean by that is we're just going to combine the name of the cation and the anion. And if we have more than one possible charge, we might have to name it twice. Okay, so this really isn't any different than what we've already been doing with ionic compounds. Okay, so if we look at an example together, calcium and nitrate. So I want to write my formula. I want to name this compound. So let's do my formula first. Again, it's an ionic compound. I know it's an ionic compound because I have a metal and a polyatomic ion. Because it's an ionic compound, I should look at my metal. Does my metal have more than one possible charge? Nope, it's in a tall column. So I'm only going to have to name this name this once. Okay? So to write my formula first, symbols. So what's my symbol for calcium? Ca. What's my symbol for nitrate that you have memorized? NO3. All right, charges. Calcium's in group 2A. It has 2 valence electrons. Is it easier to lose 2 or gain 6? It's easier to lose 2, so it's a charge of +2. And if you want to do symbol charge and then symbol charge, that's fine as well. Nitrate, on your helper sheet, right, and that you have memorized, it has a charge of -1. I crisscross down just the numbers. And notice, I'm going to need more than one polyatomic ion, so I'm going to have to put it in parentheses. So my formula is CaNO3 in parentheses, a 2. Naming this, calcium ion, nitrate, so the name of this is calcium nitrate. So, again, I have some examples that I want you to try. Strontium and sulfate, ammonium and sulfite, calcium ion and phosphate, and K and CrO4 -2. So for these, write the formula, name them, Again, if you need more time, which you probably do, pause the video, go ahead and do them, and then listen as I work through them to make sure you've done them correctly. So strontium and sulfate. I know it's an ionic compound because I have a metal and a polyatomic ion. So I'm going to do symbols, charges, crisscross, lowest whole number ratio. My symbol for strontium is Sr. It's in group 2A, so it can lose 2 or gain 6. It's going to lose 2 with a charge of +2. Sulfate is what you have memorized. It's SO4 with a charge of -2. I crisscross down my 2's, but remember my last step is to make sure it's the lowest whole number ratio. And a 2-to-2 ratio is not the lowest whole number ratio. It would just be a 1-to-1. So this would just be Sr, SO4. In terms of naming it, it's strontium ion and sulfate. So its name is strontium sulfate. So ammonium ion and sulfite. Again, I know this is an ionic compound because it has 2 polyatomic ions. So I'm going to do symbols, charges, crisscross, lowest whole number ratio. My symbol for ammonium that you have memorized is NH4. It has a charge of +1. Sulfite, now that's not the one you have memorized. So you're going to look at your helper sheet. Sulfite on your helper sheet is SO3 with a charge of -2. I crisscross down my numbers. Notice I'm going to need parentheses. Okay, so it's NH4 in parentheses 2 SO3. And naming this is going to be ammonium sulfite. Next I have calcium ion and phosphate. Again, I know it's a ionic compound because I have a polyatomic ion in it. So I'm going to do symbols, charges, crisscross, lowest whole number ratio. My symbol for calcium is Ca, charge of +2. Symbol for phosphate you have memorized is PO4 with a charge of -3. I'm going to crisscross down. Notice I'm going to need parentheses. 3-to-2 is my lowest whole number ratio, so Ca3, PO4 in parentheses 2. And I'm going to combine these names, so it is calcium phosphate. Lastly, I have potassium and chromate. So again, I know it's a polyatomic ion, ionic compound. Symbol, potassium's charge is a +1. It's in group 1A. CrO4, charge of -2. I crisscross down. I don't need parentheses because it's a 1. So I have K2CrO4. And this is potassium. And CrO4 that you have memorized is chromate. All right, your homework, page 156, 32 through 36. Have a good day. Talk to you tomorrow.